All right, my last example is simply to use the bar graph and the results to answer the following questions. What is the experimental probability of rolling an even number? Okay, so experimental means what actually happened. So I need to look over at my table over here, and I know I'm trying to roll an even number. So I'm going to come up with the probability of an even number. And so I need to decide, do I want to find out how many total are even first or the total number of rolls? And it's a lot easier if you come up with what the event is, and then you can just add in the rest to that total. So the even numbers out of my dice here, or my choices that I rolled, would be the 2, the 4, and the 6. And so I'm going to add those all amounts together. And you want to look at the top because it actually has the amount, whereas if I look over, I can't guarantee. I can tell that it was 53 for 2 and 52 for 4 and 48 for 6. So 53 times I rolled a 2, 52 times I rolled a 4, and 48 times I rolled a 6. So I'm going to add those three numbers up, and when I add 53, 52, and 48, I get 153, which then becomes my numerator, the total number of times that I rolled an even number. And now I need the total number of times that I rolled the dice. And I know I rolled it 153 times to get 2, 4, and 6, but I need to now add in the number of times I rolled a 1, a 3, and a 5 as well to find out how many rolls I rolled. So I'm going to take 153, which is the times I rolled the 2, the 4, and the 6, and I'm going to add 48, 50, and 49, which are the times that I took to roll the 1, the 3, and the 5. And when I add those numbers up, I get 300, which means I rolled the dice 300 times, so my denominator is going to be 300. Okay, now I can keep it as written as this. I can simplify it, which can be written as 51 hundredths divided both 153 and 300 by 3. Or I could write it as a fraction of 51%. Or you could write it as a decimal of 51 hundredths. Any of those would be the probability, the experimental probability that I rolled an even number. Typically, people are going to write it as a fraction or a percentage. You don't see it as often as a decimal, but you can write it that way. B, how does the experimental probability compare to the theoretical probability of rolling an even number? So in order to compare it, we need to actually find the theoretical probability of an even number. So the probability of an even number equals, well, the total number of outcomes that I have when I roll a dice are 6. You have a 1, a 2, a 3, a 4, a 5, or a 6. And the total number of times that I could get an even number are 3, a 2, a 4, and a 6. And I can simplify 3/6 to equal 1/2. So I have a 50-50 shot, or a 1/2 probability of getting an even number, theoretically. And now I need to compare it to what I got in A, the experimental. And if you look, they're really close. 51% and 50% are pretty darn close. They aren't exact, but they are close. And actually, my experimentally is slightly higher than the theoretical. So I could write the experimental probability is 51%, which is slightly higher than the theoretical probability of rolling an even an even number at 50%. Because the probability of rolling an even number theoretically would be a 50% probability. And that is a comparison between theoretical and experimental.